All right, welcome everyone to our first math lesson of Algebra 2. Today is Thursday, August 27th, 2020. On top of your notebooks, we're just going to go ahead and write the date. We'll do this every day. And then we're going to write our topic for the day, which is factoring, where A equals 1 and A does not equal 1. Let's dive right in and talk about what we mean by A. So, if I have the polynomial 2x squared minus 3x plus 5, our letters A, B, and C are the three coefficients in order. Hopefully you should have seen this before, and if you haven't, yes, it really is that easy. A, B, and C are just the coefficients up front. Now, what if we had a polynomial that looked like this? Remember, there's always an invisible 1 up here. If we don't see a number up front, we call that an assumed 1. So our A in this case is 1, our B is negative 2, and our C is positive 1. Great. Let's dive right in. From Math 2, you all have seen factoring, so hopefully some of this is review, but just in case it's not, I'll try to go nice and slow. All right, our first step, we're going to use the X method here. So our first step is going to be to create our X. In the top of the X, we put the A value times the C value, and in the bottom we have the B value. Let's fill that out here. All right, my B value is obviously 2. Let's write this out actually. I have A is 1, B is 2, and C is negative 24. So up top, I've got negative 24 times 1 is still negative 24. All right. Now we want our factors of negative 24. So as a step, I'm going to write this as factors of A times C. Great. Factors of 24. It doesn't matter if it's positive or negative. We'll deal with that when we're trying to add to 2. So obviously I've got 1 and 24. That's not going to add to 2. Let's go down to the next one on the list. Does 2 go into 24? Yes. 2 and 12. You can't get that to be 2 either. Does 3 go into 24? Yes. 3 and 8. Can we get that to be 2? Nope. Does 4 go into 24? Yes. 4 and 6. Aha. Now, if I take a positive 6 and a negative 4, those are going to add up to 2. Now I can immediately take these guys, and they will be my factors. So my solution, and we keep the sign that it has, so my solution is x minus 4x plus 6. We're going to box that so we know it's our answer. Now we're going to do a little bit of vocab. Each one of these guys is called a factor. X minus 4 is a factor, and x plus 6 is a factor. These are both factors. All right, let's do our next one. I'm going to go a little bit quicker here. Make my x, a times c. Well, let's write out a, b, c. A is 1 because we don't see a number. B is positive 3. And c is negative 18. AC up top, negative 18 times 1 is still negative 18. Our p value is 3. Okie doke. Now we need factors of 18. We got 1 and 18. That's not going to help us get to 3. Does 2 go into 18? Yes. 2 and 9. Can't get 3 out of that. Does 3 go into 18? Yes. 3 times 6. Great. We can easily get that to be positive 3 if we take a positive 6 and a negative 3. I've got my two factors, so we got our answer. X plus 6 times x minus 3. Each of these are individually a factor. Always remember, guys, if I'm going too fast in the video, please pause it. Pause it, rewind it. There's nothing wrong with pausing it and saying, ooh, he was going too fast. Let me pause that, rewind a little, and hear that again. All right, so if you need to pause, but I'm going to move on. Okay, we have our second type of problem today. Our first type of problem was when a equals 1, right? Because each of these had an invisible 1 up front. But down here, a is not 1. A, in this case, is 3. So our first step is still going to be our x. We want a times c, and we want b. Okay, let's write out what a, b, and c are. We got 3, -2, and -5. So I'm going to do 3 times -5 is -15. We've got -15 and -2. So I want factors. We always take factors of this guy here. So I want factors of 15. Remember, we'll worry about positive and negatives after. So you're always going to have 1 and 15. That's not going to get us to -2. Does 2 go into 15? No. Skip it. Does 3 go into 15? Yes. 3 and 5. I can take a -5 and a +3 to get to my -2. All right, we got our two factors. But wait, we have an extra step here. When a is not equal to 1, in this case it's 3, 3 is not the same as 1, we need to make a box. And I'll go through this nice and slow. Okay, I'm going to go below my line here a little bit. Okay, you've probably seen this before. Hopefully it's somewhat familiar, but if it's not, I'll try to move slow. In the top corner of our box, we're going to put this 3p squared. So next, I want to take out common factors. So I think what times what is 3p squared? Well, that's 3p and p. Right? Because if I go back inside, I have p times 3p is 3p squared. We see that it works out. Okay. Now I need to take these two guys here in green. I'm going to color code the box. Green goes with green. Well, let's look at this. This box right here, it has a 3. So we are better off picking the number that divides neatly with 3, which is going to be 3 and not 5. So I'm going to put 3p here, -5p here. Now we ask ourselves, 3p times what is 3p? Got to be 1. 1 times 3p is 3p. Up here, we're saying p times what is -5p? It's got to be -5, because -5 times p is -5p. Now, your last box in the bottom right, 1 times -5, -5. This is good because it's your final check. If this number matches your original C value, that tells you you're right on track and you did everything fine. If that number's wrong, it's a good way to catch yourself, because then you know you went and made a mistake. Those numbers should always match. And then we have our solutions here. These are our factors, and we're going to write them out nice and neat as factors. I've got 3p minus 5 and p plus 1 are the two factors. Great. I got one more for you. Again, if I just went too fast there, pause and rewind. Nothing wrong with that. Cool. So first thing I want to ask is, do I need a box? We need a box when A is not equal to 1. What's our A value here? Well, that's our first one, and it's 2. So yes, I definitely need a box. A is 2, B is 3, C is negative 9. Okay, I'm still going to make my X first, though. Okay, I need to do A times C. 2 times negative 9, negative 18. B value, positive 3. Now, some of you are probably pretty good at mental math, and you don't need to write out the factors. That's fine, but eventually we'll start hitting problems of larger and more complicated numbers where you're going to need to think back to this strategy. So no, you don't have to do it every time, but it's important to remember that it's in your toolbox. I wrote 15, I meant 18. So 1 and 18, is that going to help us get to 3? No. Does 2 go into 18? Yes. 2 and 9, but that can't get us to 3. Does 3 go into 18? Yes. 3 and 6, that can get us to 3. So I've got, if I do a positive 6 and a negative 3. Great. Step 2, we're going to make our box. Why are we making our box? Because A was not equal to 1. I'm going to draw a dividing line from the last problem. Here we are. Okay, let's color code a little. Top box is always the whole first term. So my top box is 2n squared. What makes 2n squared? 2n and n. Next, I'm on to my green boxes. What values do I have there? That's my 6 and 3. But how do I know where to put 6 and where to put 3? We need to think which one divides nicely into 2. 3 certainly doesn't. It's got to be 6. It's a positive 6n, and this is a negative 3n. 2 times what is 6? That's going to be 3. N times what is negative 3? That's going to be negative 3. Great. Got our solutions here, and we're going to write them nice and neat as factors to get it fully correct. So I've got 2n minus 3, n plus